This segment is the single 10 frame. It's part of the patterning and partitioning sequence that we've been talking about for a while. These activities are intended for very early in the first grade, right after the dot pattern activities. First grade teachers often will devote up to 4 weeks for this sequence, combining them with other activities from the patterning sequence. For example, a typical lesson might involve a few minutes devoted to finger patterns, followed by single 10 frame flashing, and ending with a 10 frame game. In kindergarten, they will be used much longer, of course. I'll make a comment here. This timeline shows only 6 weeks, but actually teachers typically extend this to the first 9 weeks of the school year, using 4 days a week and reserving a 5th day each week for other math activities that are important, like the forward and backward number word sequence, counting by 2s, 5s, and 10s, and the important area of geometry. Patterning activities include finger patterns, dot patterns, which describes numbers up to 6, and then the single 10 frame takes numbers up to 10. And as we've said before, with the dot patterns, most people and even some animals recognize quantities up to 4. And so once you get beyond with larger numbers like 6 and 7 and so forth, it's useful to have some means of organizing it. We've chosen the single 10 frame for that purpose. And just like with dot patterns, with the single 10 frame, students are encountering patterns that have already been formed by somebody else. They're not creating them themselves. So the instructional activities we're going to describe here are 2 types. The first type is 10 frame flashing, and the second type is the 10 frame card games. Before we introduce the flashing, we're going to describe a scenario that we use to introduce the 10 frame. So the scenario is that there's a farmer named Earl, and he has an apple orchard, or maybe you want him to have a pumpkin farm, but we're going to talk about an apple orchard. And he brings his apples to his stand in crates that look like this one. Here's Earl's crate. Okay, now before we talk about the crate, I want to say a little bit about the scenario. This is what Earl's crate looks like when it's full. So you can see that there's 1 apple in every box. Now, why do we use a scenario or a story? Well, we use a scenario or a story because we want children to have a way to kind of relate to it. They can think about helping Earl, they can think about putting apples in his crate, they can think about filling it up, they can think about taking apples out of his crate when they sell it to a customer. So they can think about actually acting in the situation. And the purpose of the 10 frame is going to be to try to create mental imagery so they can use their imagination of their acting to play into the mental imagery they're going to develop. Now there's another purpose for using the story, and that is it's going to make it a lot easier to ask questions. Okay. So once we have this, then we can ask students what they notice about the crate. And you can imagine what students might say. Typically, they will say things like, well, when it's full, there are 10 apples. Or if they don't say that, you can ask that question, how many apples are in the crate when it's full? Another thing that typically comes up, or if it doesn't, you can ask, is how many apples are there if only the first column is full? Or how many apples are there if only the second column is full? How many apples are there in each row? Now, the purpose of this discussion is to ensure that students are aware of how many are in each column, how many are in each row, how many when the crate is full. That's the entire purpose. Okay, now let's get to an example of the flashing activity. What I'd like for you to think about is the way the activity is conducted. So let me describe it first, and then please watch for it as we go through this. We're going to show something, and then we're going to take the visible material away. Then we're going to show it a second time, take it away a second time, show it a third time, take it away a third time. And the purpose for doing it that way is so that students will have to organize the visual material, and then they have to think about it before it comes back. So please pay attention to the way we're doing this. So this is the way the instructional activity would go. We're going to show the material, and then we remove it. We're going to show the material, and then we remove it. Now you probably notice we showed it for a little less time than the amount of time devoted to removing the material. Show the material, there it is, and now it's gone. Okay. Now we're going to leave it off while the discussion begins. What are the questions we're going to ask? The question is, how many apples are there, and how did you figure that out? So what do you think students might say? Remember, we're going to ask this question while the material is still not visible. Otherwise, if it's visible, students can just count, and then we don't know anything about the mental imagery they were developing. One of the things we know is because we have children that are at the beginning of the school year and maybe have very unsophisticated concepts of number, like we've already seen, that some of them will count all. If they count all, what we mean is when they see the material the first time, they start counting, they point in the air, they wait until the material comes the second time, they continue counting until they're finished, and they usually have to hurry to count them all during that time. Now, if a child counted all, we want to acknowledge that. However, one of the goals of this is to move children beyond counting to grouping strategies, and so therefore we're not going to devote a lot of time to that. We're not going to say, Sam, how did you count them? Point to show us which one you counted first. We're not going to do any of that. What might somebody else do that didn't count them all? Well, somebody else counted by twos. I saw 2, and then 2 more makes 4, and 2 more makes 6, and 1 more makes 7. Okay, that's another counting type solution. It's more sophisticated than the first one. So as the teacher, you might say, oh, so Maria said she knew that 2 and 2 more make 4, and 2 more make 6, and 1 more makes 7, but nevertheless, it's still a counting solution, so we're not going to devote a lot of time to it. So we'll ask, who did it another way, or maybe even better, who did it without counting? Okay, now we might have Joe, who says, I saw 4 and 3 more, and that makes 7. Now, because you're the teacher, you can see what Joe is doing. If he might use his fingers, for example, he might say that he saw 4 and 3 more, and maybe actually what he was doing was putting up 4 fingers on one hand and 3 on the other hand, and he may actually have then counted them 1, 2, 3, 4, 5, 6, 7. Or maybe he just knows that 4 and 3 more make 7. This one, however, because it's a non-counting solution, is worthy of some class time, and what your goal is to get other children involved in thinking about this solution, even though they might not have thought of figured it out this way themselves. And so you want to get them involved in the discussion. This is also early in the school year, so you may have to be directing this discussion. For example, you might say, who knows where Joe got a 4 and a 3? And that will open up the discussion. Somebody will say where they think Joe saw the 4 and where Joe saw the 3. Then a natural follow-up to that would, did anybody see the 4 and the 3 a different way? And I'm sure you can all see too by looking at it that someone might have seen 4 in the first column and 3 in the second, or someone else might have seen the 4 on top and the 3 below. Those are different ways that we would expect because students have been working with dot patterns. If somebody said they saw 4 and 3 but didn't say it was 7, a natural question is, how did you know that 4 and 3 will be 7? And that might even be appropriate to go back and ask Joe, because maybe he just said 4 and 3 more is 7, and we don't know how he figured that out. You can see here that the teacher is making the assumption that she has to be the one that pretty much directs the discussion, and that's probably going to be the case because this is early in the school year. But if most of these students had been in a kindergarten class that used an approach like this, a legitimate question instead of these 3 would have been, who understands what Joe is talking about, or even what do you understand about what Joe is saying? And that's more of an open-ended type question. Okay, so we've talked about a solution where a child counted all, a solution where somebody counted by 2, Joe's solution, where he counted 4 and 3 more if he used his fingers. But somebody might have a solution of a completely different type, and they might say, well, I know that 4 and 4 is 8, and this is 1 less, and so it has to be 7. Now, this solution is what we would typically call a thinking strategy solution, and so this is a very interesting one for the teacher to highlight. What do you understand about what Maya is saying? Or who else just knows that 4 and 4 make 8? How did 4 and 4 makes 8 help her figure out what 4 and 3 makes? So this is really devoting some time in the discussion to one of these productive kind of solutions. Okay, so what we've done is we've given you an example of a flashing solution. Now what we want to talk about is what kind of patterns are we going to suggest that you show? We're going to suggest that you show patterns in the 5-referenced format and a doubles referenced format. Why? Because we have deliberately chosen them. Those 2 patterns lead to very productive ways of thinking. And that's why we did that. On the left, you see a doubles referenced pattern. I'm not sure what's going to happen when I press this, so I'm going to do it. Yes, there you see the doubles referenced. We're just demonstrating for you to see why we call this doubles referenced. 7, it's not quite 3 and 3, it's 3 and 3 with 1 extra 1. And so when we show a doubles referenced pattern, we fill the columns equally and we have an extra 1 in one column. For the 5-referenced pattern, we fill a column of 5 if possible, and the others are in the other column. You can imagine that if we showed a 4 as a 5 reference, the first column would have 4 in it and the bottom one would be blank. So these are the 2 types of patterns that we are specifically asking you to use. Why do we do that? Because we know that children's thinking grows heavily out of thinking about doubles and thinking about 5s. And that's what we're working toward with this sequence. Okay. Another thing that, as a teacher, you have to think about is what tasks am I going to pose on a day? When you plan your lesson, you're going to have to say, what am I going to flash? Well, suppose you decide that I'm going to flash a 7, and you have a discussion. Are you going to flash something next, or are you going to say, we only had time to show that one today? That might be the case. But typically, teachers want to show more than one. I should say flash more than one. So after you've flashed 7 and had the discussion, what do you think you would pose next? And why would you pose it? That's got to be part of your planning process. Now we've shown 8 here, and just by see some of the things that children might say with the 8. Now you can see them simultaneously. We're not suggesting that you show them simultaneously. We're suggesting that you show the 7, you have the discussion, that task is over with. Now your new task, you show the 8. But what do you think that students might say? Well, surely somebody is going to say, well, there was just one more dot. Good. There was just one more dot. Well, last time Maya said 4 and 3 make 7. There's one more dot. Oh, if you have 7 and one more, that makes 8. But somebody else is going to say, I saw 4 and 4, and that makes 8. What's happening here? 4 and 3 was 7, 4 and 4 is 8. So this linking that's coming up because of what different children say is creating an opportunity for the class as a whole to think about number relationships. I'm going to say one more thing about this. I said maybe you only have time to show and flash one thing, so you might have shown only 7. And then you're going to think about what you're going to do tomorrow. Well, maybe you'll show 8 tomorrow, maybe you won't. But one of the things we want to emphasize that it is not our intention that one day is about 7, another day is about 8, another day is about 9, another day is about 10. That is not our intention at all. Our intention is not that as a result of working on flashing, everybody will be able to say, oh, I see 7 when I saw that. In other words, our intention is not that they get good at flashing. Our intention is that through this activity, children develop all these things like a composite unit of 5, like, relating 4 and 4 is 8, 4 and 3 is 7. So we want to be sure that we don't aren't misunderstood. Okay. There are some variations on flashing. Let's go. So we might flash this, and then we might ask this question. How many more apples does Farmer Earl need to fill a crate? We're asking this question instead of the question, how many more apples are in his crate? However, when this discussion of this one is going on, certainly people will say, well, there were 8 apples there, and so there are 2 more that are needed. What's happening with activities like this one and the next one is that children are starting to develop splits of 10. So another question we could have said was, Farmer Earl's crate was full this morning, now it looks like this. How many apples did he sell? Okay, let's go back to think about that scenario. Children can think about, oh, the crate was full. They can imagine using their hand to take an apple out and another apple out, so they can think about the fact that they took 2 out. So that's another place where the role of the scenario is coming in. Okay. So we would say that 10 referenced ways of thinking about numbers are starting to emerge when you ask these variation questions. But be clear, these are much more difficult questions. Okay. Okay, a few additional comments about 10-frame flashing. The quantities 1, 2, and 3 are so easily recognized that there's really no learning involved in flashing these quantities. Just take a look. Okay, you don't really need to ever flash these. All right, another additional comment that we want to make is that all of the chips should be of the same color to create a sense of composite unit. If you look at this one that has several colors in it, you can see that the unity of the 7 is certainly lost. We want the 7-ness to be really important here. And a third comment we want to make is we're really recommended that you actually use chips that you can move around rather than have a picture that you've already created that you just flash. So, for example, this shows a 7, and so let's see what we can do. If you have it, look at that. If you have a chip that you could move, then you'd be able, if somebody said, I thought about moving that chip down there, and then it's 5 and 2, you would be able to do that with chips. So this is a kind of a summary of the 10-frame flashing, which we assume you will use probably for up to 2 weeks, maybe a little bit longer. Now, the other part of this instructional sequence are the card games that are played with partners, usually with 2 players. Most of the time, a class has an odd number of students, so you have 3 players in a group. So what we want to emphasize again is that a lesson might involve several different activities. You might start off a lesson with 5 or 10 minutes of finger patterns, then spend 10 to 15 minutes on 10-frame flash, and then the rest of the lesson might be devoted to partner games. Okay, so let's see what these partner games are. All of these games use cards that show 10 frames. So what we've shown you here is a template for the cards that's available on the website. And the template contains 20 cards. So you can see, if you look at the first one, there's a doubles reference 2 and a 5 reference 2. If you look at the second page, you can see doubles reference 5 and a 5 reference 5. So all of these are available. Each number from actually, you can see the zeros there too. From 0 to 10 shows up as doubles referenced, and it shows up as 5 referenced. So that means if you don't count the zeros, there are 20 cards. If you count the zeros, there are 22 cards. And then our suggestion is that a set of cards to use for a game is a double of this. So you have 40 cards, or including the zeros, 44 cards in one deck. And a pair of students will use a 40-card deck or 44-card deck. The other thing we want to emphasize is that throughout all of inquiry, we're trying to promote learning as collaboration, not as competition. You're not good if you're better than everybody else in the class, or if you get more problems right than somebody else. So to have that flow through the games, rather than saying somebody won, we usually say at some point the game is over. Now that's not to say that the students aren't themselves going to say, oh, I won, but that's not our the way we present it. Okay. Well, the first game is 10-frame memory, which is like a game called concentration that many teachers are already familiar with. And you start the game by, the children start the game by spreading out the cards face down in some kind of a pattern. Okay. And the way the game is played is that players take turns. So the first player picks up 2 cards, turns over 2 cards, I should say. And in this case, oh look, the player picked up a 4 and a 4. Therefore, the player has a match. You'll notice, so the cards match if they have the same quantity. They don't have to have the same format. They don't have to have 2 5-referenced 4s or 2 double-referenced 4s. When a player has a match, the player takes those 2 cards and then takes another turn. Okay, so now the player's taking another turn, turning over 2 more cards. This time, there's a 6 and a 3. That's not a match. They're not the same quantity. And so the player turns those cards back over and puts them back in the same place. Now that's an actually important part of the game, because if the player puts them in a different place, then the partner will never know where the cards are. However, you know and we know that that won't always happen when students play. Okay. All right, so player 2 turns over 2 cards and the play continues until all of the cards are gone. A few comments about the 10-frame memory game. This is a complicated game. There are 4 cards that have a 6. There are 4 cards that have an 8. There's 4 cards that have a 9. There are 4 cards that have a 1. So there are really a lot of cards in the deck. Okay, so the players have to match the quantity, not the format, so that's one of the features of the game. Now another thing to keep in mind is that there really are a lot of cards. There's, if you include the 0 cards, there's 44 cards. If you decide to leave the zeros out, it's 40 cards. For first graders, just the activity of turning over 40 cards to lay them out in some kind of a pattern is a big job. And so some teachers limit the number of cards to just have one version of each template, which means 20 cards or 22 cards if they use the zeros. What do children do when they play this game? Well, it's played early in the first grade year, and so we're going to have a fair number of children who are going to count dots by ones. Okay. Some they're not going to count by ones for the 1, 2, 3, but if the numbers are above 4. Gradually, students are going to advance in the way they play. So they're going to count on from 5, or they're going to notice doubles. One of the things that we've found is that it's really useful for the teacher to make comments to the group. Well, try to use your grouping strategies to figure out how many there are, so you don't have to count them by ones. Or even when the teacher says, now we're going to play this game before the children go off to play. Typically this will be played after the flashing activity, so the teacher can say, you know, you can use some of the same strategies you use to figure out the patterns in the flashing activity when you're playing the game. The next game is Top It. Now, how do you play the game of Top It? This maybe teachers are familiar with a game that used to be called War, and we don't use that language anymore, so but it's the same game. So how do you play the game? You share the cards, the partners will share the cards equally. They're going to keep their cards in a stack face down, and they're going to simultaneously turn over the top card in their stack. The player with the larger quantity gets both cards and puts them face down at the bottom of his stack. Now, why do we do it that way rather than having the student just keep the cards? If the student that gets the cards puts them face down at the bottom of his stack, then this game just keeps on going. They never run out of cards. It keeps on going until the teacher decides it's time to quit playing. There is a variation of the game that's appropriate for students who aren't learning anything from the original game, and that's a game in which each player turns over 2 cards at the same time. We forgot to say one important thing here, and that is this. Suppose a player, when they first turn over their cards, we said the person with the larger quantity gets both cards. Well, what if nobody has the larger quantity? What if both of them have the same number? Then they each turn over another card, and whoever has the larger number gets all of the cards. Or even if they have the same card number that time, then they keep on going until somebody has the larger ones the next time. What's the purpose of this game? Well, one purpose is just estimation, because a lot of students can tell which number is larger just by kind of seeing the, oh, this one has a lot more dots than that. In other words, they don't have to actually know, oh, you have 3 and I have 8. I just know that this has a lot more dots. So there's a natural way to promote informal estimation. Some teachers would prefer that the children know the quantity each time, and in that case, then some teachers just sort of ask, okay, every time you play this game, when you turn over a card, you should say what number you have. We might also note that some teachers choose to play this game top it before 10-frame memory, and that would be especially appropriate if you're not going to insist that they say their number and you just want to highlight the estimation aspect. The Make 10 game is a variation of 10-frame memory. So you start the same way as 10-frame memory. The students turn the cards face down in some kind of a pattern, and the first player turns over 2 cards. This time you have a match, not when the cards show the same quantity, but when the numbers together make 10. So the play continues until all the cards are gone. So the purpose of this game is to develop partitions of 10. This game really isn't appropriate for children who don't yet recognize most of the 10-frame patterns. If they're still counting all of the dots, this is not an appropriate game. So those children should still be playing 10-frame memory, but children who really have recognized almost all of the 10-frame patterns can move on to the Make 10 game. One more feature we might say is a lot of teachers find it helpful to have more than one game that you can play with the same deck of cards, because as a teacher, you know that you want every learning activity you're providing for your students to be one where they are genuinely learning something. So if you have a pair of students who aren't learning anything new from 10-frame memory, then they can go on to the Make 10 game. This brings up one more remark that should be made, and that is, you know, who do you pair together? Well, it's really important to pair together children who are of like cognitive ability, because if you pair a student that has already developed a lot of the concepts with someone who is a lot less sophisticated, what's going to happen is the more sophisticated student is just going to tell a less sophisticated student what to do, and the result is that that child isn't learning anything, so it's not a productive experience for him. Some other variations of the game. We've encountered teachers who've decided that it was really useful to sometimes create a set of cards that have some of the 10-frame cards and other cards that are numeral cards. So you might have the initial 20 cards with the 5 referenced and the doubles referenced, or 22 if you're using the zeros. And then to have numeral cards, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you have to think about how you're going to do that. For example, remember that the 7 is doubles referenced and 5 referenced. So does that mean you want to have 2 numeral 7 cards? Are you going to allow the student to call it a match if he has a 5 reference 7, a doubles reference 7, or do they have to have a card with dots and a card with numerals? Those are the kinds of things that we know you as teachers have figured out in other kinds of situations, and teachers in our experience do creative things on their own for that. A recap for the 10 frame flashing activities. When to use after dot patterns. How long? Use the flashing about 2 weeks in grade 1, up to 2 months in kindergarten. And the games, use up to 4 weeks. Stop when the children are no longer learning anything new. And then a final comment that we want to make is, please remember as teachers that the goal of these activities is not that children learn how to do the activity. It's not that we want everybody to be able to say, oh, that's 7 when you flash the 7, or oh, that's 8 when you flash the 8. The purpose is that through engaging in these activities, children advance in their conceptual understanding of number. What do we mean? Some children will develop a composite unit of 5 because they didn't have that yet. Some children are going to develop 5 referenced and doubles referenced patterns for number to 10, which means that they will be able to say 8 when you flash the 8 right away. But the whole purpose in the flashing is that there's a discussion and people are talking about what they're figuring out and how they're figuring it out, so other children can advance as they listen to them. Some will begin to develop splits of 10.
Hi everybody, I hope you found this video helpful, and we hope to be making more in the future. So let us know if you thought it was, and check back with us another time for some more videos on this page.